All right, let's get started, everyone. All right, well, thank you, everyone, for joining us for the June DataWorks Maryland meetup. We took a month off last month. I was just talking to John a little bit about it. So excited to be back. Really honored to have John again here. He's a past speaker, and if you've ever been to John's talks, they're some of the most entertaining, the most informative,
Build me
and
up
most.
too much, man. Build me up too much.
No, I'm serious. Like actually went back and looked at the video as I was getting ready for this. But John's style is very demo driven. So I think there's going to be a little bit of presentation. There's going to be a lot of demos. And John is a wealth of knowledge. So I would strongly recommend getting in touch with him afterwards if you're interested. So before we get started, just want to go through and thank some of the sponsors and then a couple quick announcements. And then we'll hand it over to John. So Variant Technologies has been sponsoring us for several years now. They're a defense contractor in the local area. If you're interested in learning more about their opportunities, you can reach out directly to them, or you can always shoot me an email. Pretty easy to get a hold of. ClearEdge is another defense contracting company in the Maryland area that does a lot with data science, data analytics, and big data. They're actually going to be working with me on a conference that I'm going to talk about in 1 second. So if you're interested in learning more about what they're offering, you can reach out to them or talk to me. And then Captivation is a more recent sponsor. They actually do a little more broad work. They do some work up in Aberdeen. They do a lot with digital signals processing. Smaller company, really great owner, friend of mine. And if you're interested in learning more, I would definitely reach out to them or talk to me. And then my company is Arius, and we're having a lot of growth right now and having some success, and we're trying to do some interesting things. I'm always interested in talking to people, even if you're not interested in joining. I just like meeting people and talking about the industry and what we're doing. Feel free to reach out to me. That one's pretty clear. So with that, let's do a couple quick announcements. So next month, we're going to have another virtual event featuring Hannah talking about DataWave. DataWave is actually an interesting tool. It came out of the NSA. It's related to Accumulo, and it kind of helps with data indexing for large data problems. She's really an expert in the field, and I've seen the talk a couple years ago, and it's really good. It's really interesting if you're interested in the product. And then August, which I don't have on here, and I'm really close. It's like 90% certain at this point. It's going to be live. So we are going to go back in person in August. I've gotten some folks reaching out to me that were interested. We'll see what the current situation is with COVID and masks and everything, but things are open up, and it's going to be on quantum computing. And that's going to be down at actually Betamore in Baltimore. So we'll be returning there. It's a nice, spacious area. So I thought that was pretty safe. We still have the newsletter. All our sponsors are always hiring. I'm always looking for people to speak or be involved in the group, however you want. We're actually working with we're starting to work with the Data Science Corps, who's doing some work for us to try to do some analysis on our meetup enrollment. We're trying to get some work with the BNIA. They have a need for people that are interested in working on projects. So if you have any interest in this thing, just shoot me an email, and I can always try to see if we can help you. And then we are trying to do a conference this year. I've been trying to push it. It is going to be virtual. The idea is really to try to give it a test run and see if we can do it. So we're trying to get some local companies, some local speakers to really talk about different things. Really 3 tracks one day: data, analytics, and exploration. So really topics like data visualization or how you're doing large data science problems, technology. It's free. So there's really no cost. If you're interested in joining, we might try to give away some swag. So if you're interested, I would recommend going to the website. If you would like to speak, I would love to have speakers. We need more speakers to submit a talk. Please do that, and we're going to go through the selection process probably the next month or 2.
When's the deadline for that?
You know what? This is the first time I've done a conference. So I'm not I actually forgot to put a deadline out, so I have to fix that.
That's important. That's what drives me a lot of times.
Yeah. I mean, probably. So I think the event's September 18th. We'll probably do probably end of July is what I'm thinking. Being it virtual and stuff, it's the logistics, the setup isn't too bad. It's going to basically be Zoom again. We might add a little bit of mix, like we might add a Slack, and we might do a hybrid where we might do viewing parties. But I'm not quite sure about that. So probably around the end of July. But I should put that. I'll write that down to send that out. All right. So with that, everyone's kind of heard John already. So John is a fellow at Lockheed Martin, as a developer of large-scale data-driven solutions using machine learning, graph analytics, and high-speed messaging. Um, he's actually doing a lot with IRAD, and we were just actually talking. I'm sure he's going to do an introduction. He's going to start teaching at Hopkins soon. And truly, like I know I hyped him up a lot, but honestly, I do think he's one of the best speakers that I've had, because he's so interactive and so informative when he gives the demos. So last thing, I'm going to hand over to John. The way that I handle the questions is send me messages, and I will capture them. I am streaming this to YouTube. If there's folks listening on YouTube, post it in the chat there, and I can also capture the questions there. And then at the end, I'll ask questions. Or if you're okay, John, I can ask the questions as they come if they feel appropriate, however you prefer.
Okay. Well, if it's a quick one, that's okay. But yeah,
Okay.
anything lengthy, wait till the end. Yeah.
Yeah, that's fine. Okay, so with that, I'm going to stop sharing. You take over sharing, and then I'll mute myself.
Good. All right. Well, welcome everybody. Hey, thanks for coming on this beautiful evening out there. It's been a beautiful week, actually, if you're in the Maryland area. Let me actually turn this a little bigger. There we go. There we go. Okay, that actually is the first mouse that was invented many years ago. And I just thought that was an interesting connection because that changed our relationship with how we use the computer. And it's all about relationships. So a couple things. I have a few slides that give some background about how to get the vocabulary and the things that are different about graph analytics. And then we'll dive into various demos I have. I just want to say one thing on the end of these PowerPoints. I don't know that I'll get to these. I have instructions of how to get started in each one of the technologies I'm talking about. So if you want to go further or pursue the tracks that I did, learn more, because all this stuff, almost everything's available online that I'm going to be working through. And it's just a lot of fun stuff. So I'll tell you exactly how to get started in the slides for all the different technologies. So download those slides later if you want the actual details of how to go further in this. So, all right. So a couple quick introduction slides here. In my opinion, all data is a graph. And it all started with the 7 bridges a long time ago and the traveling salesman. Those were all well-known problems that are partially solved today. But if you think about computer networks, social networks, maps themselves, the internet, it's all about the relationships that you have with other pieces of information. And that really forms a context around how you're doing things. So in terms of value, the relationships alone can give you insights. If I'm monitoring activity of my phone and I see it changing, I don't even have to know where it's changing, who is calling, who's not calling. Just the fact that it's changing might be enough to tell me something's different. Or my internet use at home. If I was monitoring my computer at home and all of a sudden something's changing, maybe it's changing at night too, which could give another contextual factor to it. But it's all about graphs and patterns. This goes all the way into machine learning. I'm going to touch about where machine learning touches this. And I was talking to Jason, that could be another talk about how you take the remnants of this and move into machine learning. But I'll get you started on that too. So that's kind of the background there. So the vocabulary, there's really only a couple things to appreciate. A node is kind of the nouns of graphs. So in this picture here, a person, a country, those would all be nodes. Also, they can be referred to as labels. You can even have a hierarchy. I'll talk a little more about that. Hierarchy can be useful. For example, one of the problems that I solved was when we had events, as I was talking about events like web events, email events, instant messaging events, financial transactions. All those are different events. And if you wanted to have a hierarchy to say, well, I just want to know all the events that are going on with John Hebeler, I could do that. Or I could zero in on one of those events, or I could have even a more subtle hierarchy. So you can have a hierarchy, and depending on the graph technology, you can take this pretty far. And I'll talk about that in a little bit. Then nodes are connected with edges, and the edges are the relationships. So in this picture, you have located in, used in, results in. They can have direction. A lot of the graph technologies have direction to it. So you got to say, I'm a friend of this person. That doesn't necessarily mean they're a friend to me. So it's just a directional thing. Most of the technologies we'll use will have direction. And then the third thing there is properties. So you can have a property on a node, a property on a relationship. And those are very useful too. So for example, up there in the picture with organization and country, they were located in that country, but when did that start? So it could be actual extra detail about the actual relationship, or it could be a property on the node itself. For example, a person could have a name. So not all technologies allow you to do properties on everything, but ones we'll be looking at allow both properties on the relationship. So I could say when the friendship happened, and that would be a relationship. And then the friendship happens between two people, and those things could be names, email addresses, their real address, and on and on and on. So those are the three main pieces, and that's kind of a quick picture, and we'll be seeing more of that in a second. So to just give you a contrast, and I'm not, these databases could all be changed a little bit, but I've played with all three of them. How would you do something in a graph versus a relational database versus a document database? And a document database, an example of that would be like MongoDB. And I've used that quite a bit. So on the left here, what I'm trying to do is show how a person is related to a course. So they're taking a course. And so the person would be a node, and this would be an edge that teaches, or there's a student. And then these would be properties, like this person has a name and an email address. And the teaches would have properties of what exactly version of this are they teaching? And when does it start date? Where is it located? And then this is the actual course. And this isn't just by mistake. This is the course I'll be teaching at Hopkins. I was very honored to talk to the staff there in their data science program. And I'll be teaching that class in the fall about really realizing an AI system as a whole deployed system and building one from scratch. So I'm just putting together a lot of the ideas for that right now. But another person could be related to this course as a student, and they have a name, and they have information about when they are a student of this. So this, to me, looks pretty clear. It's easy to understand. Now, a relational database starts off easy, and then it gets kind of confused, but that's mainly because it's transaction-based. It's trying to build transactions and lots of rules with that. So I could have a table that says, here's a course. It's in the data science program. Here's two people, and those people can have roles as a professor and a student. And I know there are other ways to do this. And then I could say that there's a version of this course. So I use foreign keys here to go up to this course ID, and this is when it starts and ends. And this is the offering that's going to have offering ID. And then if I want to actually say that someone's in that class, this is the admittance to a class. That's the ID for that. This is the class that they're going to. This is the person, and this is the role. So it's very tight. This is the constraints here would make it impossible to do lots of other weird things, like just put in a random number here that doesn't fit with a role and things like that foreign keys are good at. So this would be a transaction view of how I could do transactions. This is more of an analytic view to do analysis, and that's what we'll be doing tonight in the demos. And then a document database like MongoDB just keeps repeating information. It's not meant to be normalized. It's meant to be extremely fast. So I'd be repeating the data over and over again of the course name and things like that. There are other ways to do it, but that's how you'd make MongoDB run fast. This is how you'd make a relational database be efficient on transactions. And this is what a graph database is. Now, if you added in this gray part, and you say, what if there's another relationship between a person and some other node, like the degree they're pursuing? And so there could be another person out there in that lower gray box that's also pursuing the same degree as Susan is up here. And then if you ask the question, say, I wonder how many people that are in this degree that haven't taken this course. That would be pretty easy to ask in a graph, and would get a lot more complicated in these other two versions. So whenever you're looking at following relationships and you're very relationship rich, the graph gets to be very intuitive, and it's naturally normalized. I'm not going to repeat the course information. I just would set another relationship to it and things like that. So I'm going to get a certain efficiency. I'm not even trying to normalize it, but there's no reason for me to put another course out there. Whereas with a document database, you would definitely do that just for speed. So that's just a quick comparison between three versions. So let's talk a little bit more about the graph attributes that build the graph and what you do with it. So here I just have graph with numbers on it, just so we can talk about different things. But some of the terms that you would use and some of the algorithms that we'll be looking at is, you'll hear a degree. Okay, that would be how, if I was a node, how many relationships are coming into me would be my degree. And the diameter is basically how big is that graph? How far off? How far out? How many hops could I have as I go from one to another is a diameter. This is parameters that you might talk about and just understanding how your node is working or what the average degree is and how big it is, how many relationships reach out in different directions. And then some of the algorithms that we'll be looking at tonight, pathfinding, that's an obvious one. So these could all be cities and streets, and I'm trying to find a location through it all, or a network. I'm trying to find the best way to get from A to B. So that's a typical use of graphs. And that's what we depend on for all of our GPS systems that are getting us from A to B. Cycle detection to see, can I get back to where I am in this graph? Is there a loop in it somehow? That might be for example, if I was an airplane pilot, I'd want to eventually get back to my home. Could I actually do that with the different routes that I'm promising, or should I create new relationships with new routes? Trees are ways to break down a graph to look in different parts. Two big ones after that are centrality, is what's the main focus of different parts of the graph. This can be really useful to find out for a group of, let's say, bad people, what's their focus? What are they going after? Kind of gives the main theme. Or what is a common thing across this group of people if I was an advertiser? What are they all focused in? If I advertise there, I'm going to hit all of them. And then the second part there is community. So when I look at a complicated graph, is there a way to build clusters so I could understand how the larger graph breaks down into different groups? And that's a common clustering thing. I could use that for marketing or for other reasons to understand how my organization might be operating with each other. What are the hubs of work? What are the groups that work together? Things like that, community. Another big one, and this is actually what Facebook uses for this, is recommendations and similarity to understand, hey, this node is very similar to this node. So if I was a person and I'd say, hey, the kind of relationships that I have, the people that are related to me in some way as friends and associates, and the interests that I have and the things that I like, all those things would add up to a context that then I can compare that graph to somebody else and say, hey, those are very similar, except this person never bought this one thing or never was exposed to this one person. And that's how I might get recommendations to meet other people. LinkedIn does the same thing, or to buy a product or something like that. So you have that. And then the last one there, Node to Vector and Graph Sage are algorithms that convert a graph to usable by machine learning. Now, machine learning needs numbers, and graphs aren't numbers by default, just like it's very analogous to natural language processing. A phrase is not a number. So I have to find out a cute way, an interesting way to break down a graph to represent a vector that then I can put into machine learning, and I'll show you some of that coming up soon. Some of the characteristics of a graph are whether they're weighted or not. So these are just terms you'll hear me use. I just wanted to give a good definition up front. So weighted means when you see a relationship between two nodes, what you can do is influence that relationship by weighting it in some way. So you could think of a map that's trying to get you from A to B. They could weight a road. The road could be the relationship between 2 points with whether there's a toll on it, whether it's scenic or not, whether it's got potholes, different ways I could weight that. Another way that I used it was when we were looking at web data, and you have all these pointers of people going to all these different sites. So what I did is take just one site and count how many times they went to that site over a certain time period, and that becomes the weight. And that weight I can influence those algorithms above to favor something or not favor based on that weight. So, and they can have multiple kinds of weights. Sparse and dense kind of means what it says. So a sparse graph is one that has very few connections, very few relationships in each individual node, and a dense one would be the opposite of that. Cyclic, whether it can come back to where it started. Directed and undirected graph means, are the relationships pointed one direction and you can't assume that it's going the other direction, or is it undirected and you can assume that relationship is symmetric with both nodes. Distance is looking at the word hops. So how many hops away is something of interest to me. I might, so to go back to Facebook, I might be interested in the fact of what are my friends' friends, or what are my friends' friends' interests, to kind of expand the context of what an advertiser could look at. I might go several hops away to get other information about what's going on. And then your neighbors are the ones that are directly connected to your node. So that in Facebook or something, that would be your buddies. So what's our toolkit that we're going to look at tonight? Okay, I got three major technologies. We're going to really focus the most on Neo4j. It's very accessible and very easy to use. So I'm going to use that as the main point, but we're going to look at the semantic web, especially Wikidata, which you may or may not be aware of this, but almost all of Wikipedia is available as a huge graph. And you can ask questions of pretty powerful questions of that graph. And you can either leave it there, or you can put that and put it into Neo4j and go further. So we're going to look at that example of that. And then on the other side of the coin is NVIDIA. It's got CUDA graph, which is high performance graph analytics. They're aimed at using your GPUs. So they can actually take advantage of the GPUs. And you can quickly get to huge graphs. And so when you're at a huge graph, that's that tool. When you're at a smaller graph, we're going to look at the semantic web and some of the pieces there, and kind of Neo4j fits in the middle. So as the scale goes up, you can kind of go across there to CUDA graph, and I'll talk about why I'm doing that. And then complexity of how rich you can make the graph kind of slides the other way. So CUDA graph, when you look at some of the graph files, they're very simple. You're not going to be able to put a lot of extra contextual information, but it's very fast and it can handle huge scale. And then Neo4j is kind of in the middle. And then semantic web, you can go as far as putting logic commands in there and do first order logic, which is pretty sophisticated, but you can't do that with huge graphs. It will take you basically the rest of your life to get the inference to work. So and then the last thing I want to mention, a Dask isn't a graph analytic tool, but it's a tool I found very useful to break up huge amounts of data into smaller areas so I could fit it into the different graphs that I did. It parallelizes a whole bunch of little workers that go off and has a cool little interface that you can look at that shows how they're all like chewing away. So I might want to get, for example, how I used it. I have this huge huge CSV file. I'm talking huge. And it has all the web activity from a whole group. And I might only want the web activity from the administrators. And so I could give that task to Dask, and it goes really fast. It might take, I think it took like 30 minutes. If I gave that to straight Python, it would have taken 3 or 4 days. So it really is a nice little tool. It's a Python library that you can get. So I just leave instructions on that. So let's get started here. Oh, a couple other thoughts. You'll hear the concept of a property graph versus a knowledge graph. And a property graph, that's what Neo4j is going to use. And it has no schema. It's just basically a label that says, hey, this is my node and here's my properties. And a knowledge graph actually has a structure behind it that you can add logic to. So a vehicle is a type of a truck, a car is a type of a vehicle. And then here's where I'd put my metadata down below of my specific car. And I can actually put logic that says what a vehicle has to be. And a car is a type of, I could ask for all vehicles, and it would give me the trucks and the cars because it understands that. But even more than that, one of the most powerful things it can do is equivalence. So I could say that these, let's say I had one database that had vehicle and another one that had transport machine or something. I could just say they're equal, and from that point forward, they would be equal. And so it's a great technology to integrate things, but it's got a lot of logic that you build into it. So you can put reasoners in knowledge graphs. Property graphs much more straightforward, that's kind of the two there. You'll hear those, and there's really a fuzzy definition of both of these. This is my take on it. I've read knowledge graphs that don't have logic and things like that, but this is the way I think of them. So that sticks for now. So now I want to talk about how we'll be walking through these demos. This is what I'm calling my little pipeline that I've used, and you'll see this in the demos that we see. You start out with the data. Okay, so I get some data. Let's say I have a CSV file that has all these HTTP visits. Then I'm going to have to figure out what are the relationships that are in that data that I want to build. So I start building these lines between the elements that are up here. There might be clues in the data elements about how to put that together. Then I might establish weights across those relationships and say, okay, this line is heavier than this one for whatever reason. Then you typically think of now your graph, this huge amount of features. So I have this huge set of features that I could do an analytic on. Usually you don't want to do the analytic on all the graph, the whole entire graph, although you can. You usually say, well, I'm interested in these aspects of the graph. So you highlight a subgraph that becomes this, in this picture, the red pieces, the relationship and these two nodes. That's what I'm interested in for this particular analytic. I could pick another one for a different kind of problem that I'm facing. So now I've got my data, I've got my relationships, I've got the weights within the relationships, I've picked my subgroup. Then you start applying the analytics that I talked about before. I want to see the communities within that subgroup, what the central focus is, how similar they are, or I want to convert that piece of the subgraph to a vector so that I can feed it into machine learning to do more advanced clustering, classification. And then I get different results. But one thing I want to point out is just the ability to walk around a graph can often give you some powerful insights, and not even playing a powerful analytic, just by asking a really interesting question that's hopping through the graph can lead to a lot of interesting results. Like one of the problems that I saw was we found one of the admins was very unusual, was using a USB device in a very unusual way at weird times and things like that. And then we asked further, said, well, what computer? And he was never on his computer, he was on someone else's. And so those were all queries that we did outside of doing some of the analytics. So sometimes just the question can give you interesting things. Okay, so now we'll get into the demo section. So now we're through the slides. So what we're going to look at first is Neo4j. We're going to look at what the language is of how you ask the questions, and we'll do a little bit of the movie demo that they give you. And then I'll talk about fraud detection, Russian trolls. They have some really nice examples of this, and this will all be demos, and then also the machine learning piece. So I'm going to cut out of that. Now jump around to my, here's Neo4j. You can, I hope, if you aren't familiar with Docker, I use Docker all the time, and this is all these things that you see are different Docker containers that are running, so I can run multiple ones. I have lots of fun with that. And this is the web interface to Neo4j. So just let me give you a little background before I go a little deeper. Here you'd have all the different schemas, the different nodes and relationships that are in the database. We don't have really, these are leftovers, so I don't have any yet. Here you can have different scripts that they let you have. This is the ones that I put in here. So you can add the queries that you like, and so on and so forth. And this is an intro screen that you get right in the middle. We're going to actually do this and go through a little bit of the movie piece. But let me show you first how you how a simple way of how this Cypher language works. There's only really three that you need to know really well. Create, this would create a node. The node would be a person node, and it would have one property called name, and that name in this case would be John. So if I ran that, let's see, I gotta move this thing here. So it says, hey, created it, and it gives you a little result there. So then next, if I wanted to create a relationship, so this would be the next step up. I created a person, and now I want to create a relationship. I can use this property called merge. And what merge does, it's different than create, is if the person doesn't exist, which I forgot to put that in there. So if this person exists already, it will only use the person that exists. And if they don't exist, it will create it. So it kind of gives you both. So I'm saying, okay, I want you to see if you can create this person or see if that person exists. So it's kind of like a query and a create at the same time. And if you find that, well, you will find the person, because you're either going to create that person, John, or you're going to find the one that exists. Just call it J. So now I have this J that I can use in the rest of this expression. And here I say, okay, now I want to create the relationship where J knows another person whose name is Christy, which happens to be my wife. But so then if I run that, it would come back and it says it created one node and set one property, which is exactly what should have happened. And I could look at what created by running this command, this visualization, and you'll see what you get. And actually, I left some stuff from before, but anyway, this is the schema here for person. I thought I deleted everything out there. So anyway, sorry about that. This is the person that I created. But if I wanted to find the person, here I'm just going to use my match command. So now I had the create, you have merge and match. Those are the three big ones for this language. And now I say match a person, match any person you could find, and return that person. So if we look at that, this is where we should get what I was hoping to see. And you see John knows Christy. And actually, it draws some really pretty pictures, and we'll see some coming up later. It's very effective to get visualization of what you're doing. So really, those three things are the main parts of the language. Create, to create something. And if you notice, if I went back up here, is they separate a node, always has a parentheses, and then relationships always have square brackets. And then one other thing I didn't point out is you have to have a direction. And here I'm saying that John knows Christy, but it doesn't necessarily say that Christy knows John. So I'd have to create another relationship to say that. And that's basically the language. So if we gotta move this thing again, here we get rid of some of these screens. So now I just have a couple things to go through to get you started in this. Here's the movie graph. Just have a couple of things I want to show you here. This is sort of, it reminds me kind of a Jupyter Notebook version that's just devoted to Cypher, if you think of it that way, because they can put text, they can put pictures, and they can put real code. And so it's a little different because the code pops up here, but they're just going to create all of these people for this to show you this little exercise of Cypher. So they're creating a movie. So this first line here, if you look at that line, it's saying, I'm creating a node called movie. It has a title in the matrix. It has a released property, 1999, has a tagline, and then it's creating persons. And then it's down below, it's taking those persons and telling what movie they acted in. So you just kind of get familiar with this language. I think it's pretty intuitive. It's pretty easy to get used to. And you can see here, they put a property on the relationship itself. So they say acted in and the roles as Neo. So basically the person, they're telling you what was the role that they played in that movie. So the relationship saying I acted in the movie, but then they're adding in the relationship, what was the specific role? So you can see the advantage of properties on all three. So a node, I can describe the node better, but a property, I can describe the property better. And that's what they're doing here. So I just load that up and run that, and then it will run. And then it creates this nice little picture. And you can look at it other ways too, tables, text, things like that. So now I've just I populated the database essentially. So now get rid of that picture. And I just want to show you one more thing here, and then we'll leave this. Here's some fancier ways of doing queries. He's saying, so this is saying I'm looking for, and this is the classic Kevin Bacon thing of how far you're related to Kevin Bacon. Now the relationship's not mentioned here. Okay, there's no name for the relationship, just star 1 ... So what that says is I'm willing to go 4 hops out. So 4 hops, I don't care how I'm doing the hop, although you could also specify that I only want to follow one type of a hop, or actually you can follow several types of hops. You can do ors. This is saying any hop, I want to know anyone between that and then whoever is, this is just a free variable, anything that's related to Kevin Bacon. Basically, that says anything at all that's related to Kevin Bacon up to 4 hops out. So if I played that, you'd see how all the different relationships that come back from Kevin Bacon, and there might be a better way to look at this. These are all the things that are related to Kevin Bacon in this relatively small database that we created. And then to show you another twist on this is this one here says specifically Kevin Bacon, and you can see it has a star here. That means I'll go as far as I possibly can. The other one limited said only give me 4 hops out. So that's 4 relationships. This says give me anything. And then there's a little warning, and it's basically because that's unbounded. This could be a disaster. I mean, you could be searching forever if I keep following another path, it could find something. So this is saying, how is Kevin Bacon related to Meg Ryan? So here I don't have just any variable. I want to know specifically how Kevin might be related to Kevin Bacon, and what's the path between Kevin Bacon and Meg Ryan. So you start seeing advantages that would be extremely hard to do. This graph here would be better. So this is So this is the path where Kevin Bacon acted in Apollo 13. Well, so did Tom Hanks, but Tom Hanks also acted in Sleepless, and Sleepless then was where Meg Ryan was. But just give the availability of how hard that would be in other technologies to do this kind of hops, either whether you contain it with the 1 through 4 or to go further. So it's really cool that way. So that's the first stop. Okay, so this is my own, and we'll be coming back to this is my own Neo4j. But also Neo4j has a whole set of projects that you can work on, and they'll give you all of the computer power to do this and remotely plug into the screen, very similar to what you just saw. And this is where I'm going to step through and show you different pieces of this. And I'll give you the links in the handouts. You could go on these, and there's a whole bunch of other projects that they have here too. I just happened to pick these because they were kind of illustrative of a couple examples. So I have them running here already. So this is the fraud detection. Is this, by the way, Jason, is this big enough for people to see this print, or should I make it bigger?
I mean, I can see it, but I'm on a pretty big monitor.
If anybody complains, let me know and I can make it a little bigger.
If you can't, they can post it in the chat and we can watch. But okay. I mean, it looks okay to me. I've been watching it.
So in fraud detection, you're looking at the people, the information that they have, and how they share it with other people. Because what it's trying to do here is use a technique to find the group, the clusters of fraud groups, and how they're operating together and what information they're sharing with each other. So down below, there's first-party fraud, which would be the direct person who's doing the fraud. And second-party fraud is how I might be sharing with other people that might also be doing it. If you follow this thing all the way out, and we don't have time to go all the way through it, it starts looking at inferred relationships. So it starts predicting relationships between fraudulent people, like this person probably will give this information to this other person, things like that. It's really quite cool. So it's got 45 different steps that you can go through. This database is already loaded with this information, and that's what this call here will give you the different sizes of what's going on. I'm not going to go through that right now. So the pieces I wanted to show you here for this one was, okay, I talked about that already. Then we'll go to 4. So this is the schema. So this is a way to look at that schema, what the schema they have. So basically, actually you can blow this up. So as you spread this out, you start getting an idea of what's in here. They've got social security numbers. So this would be the merchant, the transaction. This is actually a real database that they use, that they picked on this, the bank, client, the person that shared the information. Then you start to see all the relationships between them. And then the social security number is a private number that they want to see if that's shared, how the money was paid, the merchant. So you kind of see how they put this together. Let me get back here. So there's a lot to absorb there, but you can play with this. So now we're going to go to 5, next one. Oh, already did that one. 13. It's the next one. So now I want to use a relationship here. I want to create a new relationship. I want to start to find client who has emails and phone or so I'm looking at these 3 relationships. So I want to see a client who has any one of these 3. So this is an or, and also another person who has similar ones. So another person who has those relationships, and I want to see if any of the identifiers are the same. So in other words, they're sharing information. So you can see how this is, we're moving up in the Cypher world. So it's basically counting how much they share between the 2 of them, shared identifiers that are the same. And that's what we'll run. And and then this merge will add it into the database. So now we're creating a new relationship. I don't know if I already ran this or not, I can't remember. Okay, so I already ran this earlier to test this out. So now I've added that. So now I can move on to 13. I'm sorry, 18. And this is the first thing what we're going to do is we want to break up the groups so we can see what groups are working together. And this is one of the first clustering analytics called weakly connected components. So it's actually looking at the weak components to break them apart and say, these are the groups. So this is creating a subgraph. So when I talked about a subgraph before, it's looking at the subset. And in this case, it wants to look at shared identifiers, and it looks at a property called count. So it's looking at how the different groups are sharing their identifiers together. So I think I already ran that one too. Oh, okay, so I did delete it. So it ran it and it created a subgroup, and then it basically tells you how many nodes are in that subgroup, how many relationships, and how long it took to do that. Now, once I have, I gotta move this little window around again, get rid of that. So once I have this subgroup, now I can run the analytic on it. So I've just created the subgroup here, like I was talking about that pipeline before. So now we'll go to 21 and we'll run the actual subgroup. So this will actually, this is the call to the analytic in a Neo4j to basically do clustering on the subgroup that we gave it. And that subgroup is this WCC. We named it WCC. And it's going to return a couple things. Actually, just did it. So if we want the results from that, we want to visualize how it broke it up. We go here and look for what it actually did to the system. And here you start to see the groups. Let's blow that up. So here's the subgroups that it put together that are all working together as a group. So then we could start to see how we want to go about this. So now it's not one big graph anymore. We can break it down and say, this is a group that's all sharing information, this is sharing information, and so on and so forth. So I think there's like 6 groups that broke down that information to. So that's, and then they go further to say, how does this group share information with other groups, and goes beyond that. And it's a great little project to play with as it goes further. But this would be the first analytic that's using the concept of weakly linked. So it's looking at how nodes are tightly linked to each other and then loosely linked to someone else, and then basically breaking them off and say, okay, that's a group that's working together, and so on and so forth. So in the process, it's building a cluster that's a smaller group that has decided that it's working together. So that's the fraud group. The next one I want to show you is the Twitter trolls. Okay, this is where they're trying to analyze. This is also using real data from Twitter to analyze how a troll might be working. And this, I got a number of things. So we're going to look at what information they're sending. Let me get rid of that for a minute. If we go to, let's see, I want to make sure, go to the right one here too. So this is the data model. So you can see this is the actual nodes and relationships here. They have source, the tweet, who the user was, what hashtags they might have used. So this is it's a relatively simple graph, and they've got some relationships there. So we've got this data squirreled away. Now we'll go to 7. And if we wanted to see something like the volume, so this is saying match the number of tweets that were created on a certain date and order by a certain day. So you start to see regular kind of syntax here for a database, and it'll come back, hopefully. It's a lot of data on this one. And it'll say how many tweets per day, and the days are all in order. So that could be just some background information that you might want to know about. I gotta move this thing again here. Let's see. And then I want to go to 14. Here's another one we're going to use. Centrality is to understand what is the focus of these tweets. And there we're going to use PageRank, which is the algorithm that Google uses for highlighting what it returns to you. So we're going to call this a minute. And the PageRank takes a little bit. And it's added to the database. So to get the answers, we do this one. And I think this one will tell us now. So this is showing what is the most popular troll by PageRank. So and kind of get an idea of how much stronger one is another. So this is saying the most popular central troll. So this might be a leader versus somebody much further down the line. And that's using the PageRank algorithm in this one. So that's kind of cool. And let's see, what else did I want to show on this one? And that's, I think it was 15. Also community detection, same kind of thing. This is using a slightly different algorithm, but it's also doing clustering. So we can see, I think this is this one that draws the pretty pictures. I'm trying to remember. What's the next one? This is basically telling you the members that are in each group. So this is showing the clustering of the users and how they're working together. So then you could use that with, and there was the top person who was the top from the other one. So this is another clustering technique. I thought there was a cool picture here that I could draw. Maybe that's the third one. Maybe that's this one. Let's see. I know one of them had a really nice picture. I was trying to. The same thing. This is other ways of looking at the community. So basically, you see, how could I tell what's the popular or central thing here? What's the one that everyone's talking about? And how are the groups broken up so that it could understand how they're working together, similar to the fraudulent one. So that's the fraud one. Then I got lots of stuff to show you tonight, so I got to keep moving. But put in your questions, and we'll get to that. This is another one that they did for data science. If you like I'm trying to remember the show this is about. This is about, let's see, get rid of that one. Hold on. Go back to the beginning. This is a library for Game of Thrones. That's what I was trying to think. It's Game of Thrones, and they're trying to look at the different characters and how they are. And I wanted to show you a couple algorithms here that are interesting. So here is the data model that they use. So if I blow that up, you know, they have the different characters, and I'm not familiar with this, and so this didn't excite me as much, but they have a lot of interesting code in here to look at. And they're looking at what are the most popular characters, what are the characters that get the most interactions with other people, and things like that was all with this built around. Just want to show you a couple pieces of this. So if you looked at, let me get rid of this for a minute and go here. This built up how people interact with each other, and you can see the number of interactions. Oh wait, this is 6. Sorry. So this is just looking at the number of interactions per character, and I wanted to go to 23. Again, page rank was here, so you could see. I could run a couple things to set this up and clean up some of this screen here. All these things kind of just pile up until you delete them. And let's get that run. And then, okay, I already created that already, I think. And do that. So this is the page rank of the different characters and how popular they are, how central they are to the book. I have no idea if this is true or not, but it's just another concept of seeing who's popular. Another way we use this is if you had a suspect of insider threat, for example, and you wanted to know what was their focus. So you might see, and this could aid in whether you think they're just doing something unusual or they're doing something wrong, is you could say, let's say somebody's context has changed. So now they're doing something different. And in doing that, what was the center of their work? And then you could see what are they focusing on getting, a data element or a certain machine or a certain concept or a certain topic or domain, or they're outside of their normal domain. These are things you could use for central, to centrality. And then the community could say, who else are they working with? Is this a group of people that is doing this, or is it all by himself? And if you're all by yourself, that might be a higher probability that they might be an insider threat versus working with a normal group, unless you think the whole group's bad, which is another issue there. So that's a quick tour of 3 things that you guys can go as far as you want with these. They're available at Neo's Sandbox. But I have more stuff to show you, a lot more stuff to show you. So I wanted to show, oops. What is that? Oh, I see. I'm getting this bar. Okay, I gotta move that bar. Okay, so here is, so I'm going to go to, I wanted to show you, I have used this node to vec at work. I couldn't bring that piece in, but I wanted to show you, they didn't have node to vec. Now this is where we start getting into machine learning. So how would you convert this to machine learning? Here, node to vec, if we back up and think of natural language processing, the problem with natural language processing I mentioned earlier is we have to take a phrase or a paragraph and change it into a vector, a series of numbers. Those numbers somehow must represent what is that phrase is. So actually, to back it up further and think of a photograph. Okay, a photograph, we want to teach a machine learning system how to recognize a car or a stop sign. We can't feed it a normal photograph that would have millions of pixels and millions and millions of numbers in it. Would overwhelm machine learning. So we have all these techniques to kind of squish it down, and that's where you get convolutional neural networks, where they do all these convolutions to shrink it down. And you've got to come up with similar concepts for natural language processing and for graphs. So they have to say, okay, I've got a graph. How can I take this node and give it a unique number that somehow recognizes what it's related to, versus maybe just one hop away or even two hops away or more. And so there's different techniques to do this, and one of them is node to vec. So what it's going to do is take random walks through the graph and use those random walks to refer to that one node and give it a vector that is unique because of the different walks that it took versus another node, which would take different walks. So each one of these nodes will get a vector that represents as much as it can its context of its relationships with all of its buddies out there. And then that vector can be fed into a thing. So I'm going to take, we're going to go back to my Neo4j right here. I'm going to clean it up by clearing the database. This just basically deletes everything. So now the database is empty, and I'm going to show how we would do this. So now once we go back to my Jupyter lab here. So here I'm just going to, this is a Jupyter Notebook, by the way, which is running in another container. So copy that over, put it here, paste it. So all this is doing is creating a bunch of people, and this is from their example. Actually, this is from Neo4j's example. I just create this, and I get a bunch of people. Okay, so nothing really exciting there. And then I'm going to create a subgraph. So this is my second step in that pipeline, or major. I always keep doing that with Notebook. Anyway, copy. We'll go back here and paste it. I've already created it before. But this basically what this does is creates my subgraph, and I'm interested in person and instruments. So that's the nodes that I care about for this subgraph. And then what I'm going to do, and this is the piece I really wanted to show you, is I'm going to call the node to vec, and I wanted to show you what you get from that. So now let's get rid of this. So what it's saying is use node to vec. So I'm going to create a node from a node, the nodes that I have that I care about in my subgraph, and I listed it as my graph. I'm going to convert it to a bunch of vectors. So if I say yes, wait, that's weird. Oh, wait, this should be alpha. I wonder how I got that messed up. Okay. What basically I just did there is these algorithms are released in Neo4j at different levels of maturity. And I have the alpha version, the earlier version. They just released a new one, so it would be beta, if that would be the new one. And then eventually, a lot of the GDS are all the graphic analytic libraries that they have. And actually, you have to add that into Neo4j, and I have instructions on the slide you can take home that's how to do that. And so you have to catch. So what it did was, if you look back in this code, I said I wanted 2 features for every vector. I could have had a bigger number, and then it's going to do different kinds of hops through the network. That's a relatively low number. At work, I've used like 10. So say, give me a vector translation for each one of the nodes. So every node now, this is a real node that exists. It's one of those nodes we put in there. This is our embedding. So this is what I would feed in to a machine learning algorithm that represents this node. So the next step would be, why I'd feed it into a clustering algorithm, like a self-organizing map, or I could feed it into a regular neural network to make predictions about different things that I might care about, whatever it is. But that's the step of changing a graph to a vector. Natural language processing goes through the same situation, and they have word to vec, so they'll take a set of words and convert that into a vector also, because this is what machine learning likes. Okay, it doesn't want a graph, it wants a vector, a number that represents that graph. And there's several different algorithms. In fact, there's dozens of algorithms of what is the best way to convert a graph to a vector. And the same thing exists in natural language processing with dozens of different approaches to come up with a vector, and they all are giving and taking some kind of meaning with it and losing some meaning in doing it. So it's an evolving thing to keep posted on, is how they do that. But I wanted to make sure that you saw how you get to the next step of actually putting that into machine learning. So that's kind of our Neo4j thing. Now, I want to talk about how we could use this for all the data in Wikipedia. I want to show you how this works. This is kind of fun. So if you're not familiar with Wikidata, Wikidata represents almost all of the data in Wikipedia, but it's a graph. And this is a page from Jimmy Carter. I'm just picking on presidents, and I'll show you the example that I walked through. So this is president, and it has, if you look carefully, I'm going to make it a little bigger here. They'll have words here in blue. That's the relationship name. So this person is an instance of a human, which makes sense. Here's their image, here's their gender, their citizenship. So these are all the relationships that are built into the graph for actually a lot of people. Celebrities would have similar thing. A birth name, given name, a family name, date of birth. So all, and then you can even go deeper, like place of birth, and there's several places of birth. Father, mother, the different siblings that they have, spouse, children, number of children. You see there's quite a bit to this graph, a lot of relationships, all the different occupations that they had. And you could go further, you could go drill into what's an environmentalist and what does that mean if you wanted to go deeper. Field of work, the employer, position held, that's where the president is, but he was governor of Georgia. He was what member he is of different groups, where he was educated. So you see, this is pretty powerful just on one person. Their signature, what religion they had, what their blood type is, whether they're right-handed or left-handed. And you can start to say what kind of questions you could ask from this if you start to ask the graph questions. Were they in any wars? What military branch were they in? And you see this goes on quite a bit. Anyway, all of those are the relationships. So then you come over to the query service that they have. And if you just do a query.wikidata.org, you'll end up here. And I want to talk about this, and then I'll say why you want to click on that I in a minute. This is Sparkle now. Now we're going to the semantic web, and you see a slightly different version of how you would explain a graph and how you're looking through a graph. Sparkle is from the semantic web, has a lot of cool parts to it, but one of it is a select, which is similar to a match query in Neo4j. And what we're selecting, and this is very similar to SQL, these are my variables. So in this case, I have these 1, 2, 3, 4 variables where I want certain cases to happen. This service line is and I'll talk about why there's numbers down below, is it basically Wikidata service doesn't want to be married to English. You could ask this question in any language you want that it supports, and it supports a lot of languages. So this word line here is just saying, hey, we're speaking English. And then it's saying instance of something. So here's your relationship. There's three, it's an instance of a something. And let's see. So it's instance of this. So whatever this is, and this is the human. So this is basically saying I'm an instance of a human, and an instance of, in this case, I'm sorry, President of the United States. So that's not the way you'd ever build this. And then here I want their given name. So at least you see that in English. But they have this query helper that's really powerful. Okay, so I could say, what am I looking for? And there's all kinds of drop downs and it'll find something that you match. So I want an instance of, and remember when we went to Jimmy Carter, if we go all the way up to the top, which was pretty high, there's a lot of stuff. Instance of that's where it came from. Okay, so we're going here, say we want instance of human and position held. That was another one of the blue relationship fields, President of the United States. And I want to show the given name. And in this case, I'm limiting to 100. So you can see it translated instance of to WTT P31 and human to WDQ5, because then it could be language independent by using these things. But you can just hover over this and it tells you what it is. Or, hey, I'm still on, aren't I, Jason? Everything's okay, right? I guess it is, right?
Yes, you're just
Okay,
your video
sorry.
is off, but your screen's showing fine.
Okay, my video's off. How did my video get off? Okay, I don't know how the video got turned off, but anyway, let's see. There we go. Okay, I must have accidentally hit that. So, so now you can add parameters here. So I'm going to add a whole bunch. That's given names there. I want to add family name. Family name. And I want to add, so I'm just going to add a whole bunch of things. Place of birth. Siblings. Now, when you start getting into things where there's multiple answers, okay, so they could have multiple siblings, you're going to get repeated entries down here. And this is what you have to, why you have to be careful with when we start bringing this in, because I'm going to export this and bring it into Neo4j. So siblings, I'm going to add religion. Oh, I don't know, I must have typed that wrong. Religion. And we'll go with member of what party? Political party. So you can start to see how rich a question you could ask now across all the presidents that ever were. So we have number of children. Now I have found out that some of these fields aren't always there, and that's something you have to work through too. What children they had. Oops, not father, I want child. Child, and where they were educated. So you could do all this, and now you're going to get this, you know. So if you're looking at Dwight Eisenhower, you start seeing what siblings he had, what religion, what party, father, what school. So after you do this, so these are all the things I care about in the president. So I want to ask some interesting presidential questions. Then I can go here. Got to keep moving this thing around here. I can download it as a CSV file or any of the other forms. So I download it. Put it in my download directory, save it. Now I've got all this information I just took by this query. Okay, this is the query that it ran against the Wikipedia thing. So you can see I wanted a human being who is president. That's what those first two parts are saying. And if you have it, because remember, some of these fields may not be populated for every president. For example, someone might not have a sibling or might not be married or whatever. So then I'm saying, give me their name. Their given name is like John, and then family names like Hebeler, where they were born, what siblings they had. So this could give you multiple things coming back, what awards they received. Did I put awards in there? I guess I didn't update. Member of political party, number of children, so on and so forth. So now we take that, we got that CSV file, and now let me go back to, let's see, where am I here? This Jupyter Lab. Okay, so we basically did this part here. We built that up. We got our CSV file. Now I can do this. I'm going to take this line here, copy that. So I'll talk about to my own version here. I'm going to clean up my, get rid of everything, clear the database. And now I'm going to put that line in. So what this says, it's going to load my CSV file, and that's the presidential file that I just did. I have a little different version of it for, try to move that here. That's how I must. And then this is my direct, what I'm doing is, that's just a row. I'm creating all of my relationships in here. So this is doing two things. It's getting the data and creating all the relationships. So if I have, so for example, here's my siblings. So my siblings right here. So this is going to be all my siblings. And since I keep using merge, I'm not going to repeat the president. So I won't have, if somebody had 3 siblings, I'm not going to have 3 issues of that president's node. I'm going to have one connected to 3 siblings. So that's where the merge comes in. And I make sure that things are, if they don't exist, then don't do it. So there's a lot of quirky stuff in here to make sure that if a thing doesn't exist, don't create a relationship if it doesn't exist. And I run that. Whoops. Must not have copied everything. Right. Sorry. Let me go back to there. I know this works because I did it several times. Oh, I forgot one of the parentheses there. Sorry. Go back here. Get rid of my bad mistake there. Get rid of this. We don't need that. Get rid of that. Go back to the beginning. Now run this. Take a second. So it created a bunch of labels, nodes, properties, relationships. But now think of the questions I can ask. And these are kind of fun questions I put together, like a simple one. If we look at one president, okay, we just pick up whatever president looks like. Let's see what the actual relationship looks like. So for that, we could just say match, I think it's president, match one president. Let's see, okay, whoops, here, P, and return P. And we should get one president back. I wanted to limit it to one. Sorry, that's all the presidents. Then we'll say limit one. We can go a little further on this one. So we get President Dwight Eisenhower, and you start to see Dwight Eisenhower. Let me make this a little bigger here. Make it bigger. Guess you can't make it bigger. Anyway, you see the relationships that it created. He had a son. He has a sibling here. He has education from the United States Army. That's his religion. He was Republican. He went to this high school. He had a role as president. So that's what I was able to build in that little query. Then we can ask some really fun questions. Let me make this a little smaller. So a question we could ask would be right here. So I have a bunch of questions that I just like. Find the president that has sons that were president. Now think of how hard that would be if you actually had to search for that. So this is a query that can find, copy this and we'll run this. I'm not saying this is all guaranteed to be correct because I didn't actually check all the data, but these are the presidents that had sons that were president. Some of this was repeated. Father was there. And then you could have, see, here's another one. What's the most popular religion across all of the presidents? So I need to copy that, go here. So you can see person has religion, return the type of religion ordered by members. So we'll see what, so the Episcopalian Church had 13 presidents, Presbyterianism had 7, Baptists had 5, Catholics had 3, Mennonites had 2, Jehovah's Witnesses. So and now some of these, I guess these are all different. Yeah, different. Anyway, you could kind of see that even things like is Protestantism. Anyway, that's an easy one to run. Let's see, what's another one here? Most popular school, the most popular political parties. Let's see what what is the party that wins the most as president? So we can copy that in. and it's Republican and Democrats are tied. But you can see how easy that was to write that, okay? So give me a person who has a political party and return their name and their count of the party that they were in, right? Because that's the R that's there. And order by in descending order, so you get the highest one first, and so you get the Republican Party and the Democratic Party, and then you get the other, the Know Nothings, which goes way back, the Free Soil Party. If you know your American history, those go pretty far back. But that would be a pretty hard question to ask, certainly if you just had a Wikipedia. But just by using the graph in that one line, you've got it all done in that graph. And let's see if I had any other cute ones. Find the president with the most children. I don't even know whether this is true, but it came up interestingly enough. Let's see who the president was with the most children. Let's get this out of that. So you can see I'm doing person has child. Give me the person's name and the count of the children that they have, order by the top first. And it said that John Tyler had 15 children. That seems really high to me. But some people had 10 children, which I guess is possible. I mean, if you go back in history, a lot of the children didn't make it. Jefferson had 9 children, which I think is right. George Bush had 8. I don't know if that's true. Anyway, I have to go back and validate all the data. But and then similarly, the president with the most siblings. So just have some ideas there. But the key thing there is this opens up all of Wikipedia, and now you're talking Sparkle, which is a semantic web query language. But you can see the similarities. You're always looking at kind of 3 things. What's the subject, the relationship, and then the object of what the relationship is going to. And how they express it is a little differently. So this says, okay, I want that same person. What's their name? What's their family name? And so on and so forth. But if you back it up, it's the same problem. We've got kind of a triple, which with 2 nodes on the end and a relationship in the middle, and how they form it. Sparkle, this is a very quick touch on Sparkle and semantic web, which has a whole other aspect to it that allows you to put logic in there and rules and all kinds of other things. And there's a lot of published ontologies that actually have the structure of how things work. I worked years ago on ontology with a radiologist when they were looking at how could they organize the structure in an X-ray to maintain that structure. And then they're just populating the instance data, and you can do inference across the structure. So that's a whole other topic, but there's a lot of power there. And I'm just kind of brushing on that right now. Okay, I got a couple more topics here. So we covered Neo4j and a little bit of Sparkle. I want to talk about, where's the next one? I think that's back here. This Jupyter Lab. This is, I wanted to touch briefly on CUDA. Now CUDA will take advantage. In my case, I have 2 GPUs in this machine, and it will start using these GPUs that have way more cores than my CPU to work. And this is a problem. I don't even know how to say it. This is a community detection algorithm that's also offered in Neo4j. And I'll show you some of the code for how this works. But the data is much simpler than what you would see. This is what the data looks like that the CUDA is going to absorb. And you see, this is just saying 6 is related to 7, 6 is related to 11, 6 is related to 17, 7 is related to 1, 7 is related to 5, but not to 2. And you can also have another column here that gives you a weight, and that's it. That's all this. So the complexity is not going to be there, but these numbers can be huge. It can handle trillions of relationships and give you in this case, the clustering that would happen. So if I run this, it imports the libraries there, no big deal. Now it's reading in the data. And these are all CUDA calls right here. So this is, and I give you the instructions of how to set this up too in the handout at the end of the presentation thing, how to set this up. CUDA is proprietary to NVIDIA, so you've got to have an NVIDIA GPU. And if you're going to use and this is in a container. This is a different container than the other ones. If the container has CUDA in it, you also have the same version of CUDA in your main host operating system. They have to be compatible. And then this will allow me to directly take this container and directly use the GPUs, which is something you can't do with a virtual machine, but you can do with a Docker container if it's configured up this way. So right here, it's telling you, if I run this command, NVIDIA SMI, it's saying it has access to the GPUs. So right now, the first GPU is actually being used for something. I don't know what. I have to figure out what that is because I'm not using it for video. But every time that I see it doing something, I'm wondering, what is it doing? And it's going at 91 watts, and the other one's pretty quiet. So now I could go over to here and start. This doesn't push it hard enough because of the time constraints we have, but it's bringing in this file and running, and so then it's starting the graph, and here's where it's actually doing the algorithm. So instead of Cypher saying GDS.Luvian, in fact, it has this exact same community algorithm, and then it will tell you how it broke up the groups, and then it tells you what the groups are for this particular group. So you would have to go back and say, well, what does 1 mean? What does 2 mean? Now those could be movies that I might have seen, or it could be a friend. You know, friend 1 is a friend of friend 2, and so on and so forth. But some other level has to convert it to this kind of a file so that you could use this. Now, once it's in this kind of file, then you could take advantage of the GPUs, and it could be huge. Because one of the things that I ran into, and this is why I brought up Dask earlier, is I couldn't get on my home system Neo4j to hold all the data I wanted to hold. Even though I bumped up all the parameters and stuff like that, I had to whittle it down, and Dask helped me do that. With CUDA, I wouldn't have to do that because it could just jump on the GPUs. And I got two nice 1080s from another a year and a half old now, but they're still doing and still support it. So that's the difference. So if you want to go up in scale, just like life, you're going to go down in complexity. If you want to go all the way up to complexity and have a first order logic, you're going to have to go much smaller scale. And I've done semantic web projects. They can't be that big because when you have logic engines running, reasoners running, there's no way they can take on trillions of relationships and come back in any reasonable amount of time. So I wanted to give you a little taste of that. And 2 other things I want to talk about, and then we can take any questions you have. Amazon also supports Sparkle, which, see if we can come up here. Neptune is a database that supports Sparkle and RDF and OWL and stuff like that. So, but it does not. I don't think it does research. So you could create your own database here, and then you get a Sparkle endpoint, and you could start pumping in data into there and asking queries of it. So it's and a number of companies do use the AWS Neptune to do graph analytics. So this is you could also put Neo4j on a VM in Amazon. But this is an Amazon thing that they do. And there's also, I think somewhere I have, yeah. So here is a social network recommendation that runs. I don't have this running because I don't have it connected right now to the database. But you could see, I hope you can walk away from this and appreciate the similarities between all these different worlds. Is here it's creating relationships. So it's saying, hey, I'm going to create a user's name's Bill. They have a property called birth date, and this is the birth date. So you got to see there's the triple again. And then this label, then they're creating relationships here. They have a friend, so on and so forth. And then this is the picture that you could have generated in Neo4j too. And then they're looking for recommendations of who's a friend of a friend. So they're kind of walking the graph to get that. This is all another example from Amazon's training book to see how you can interact with their world. So that's that piece. The last thing I want to talk about is Dask, and Dask is a flexible library for doing lots of things in parallel. And chewing away at a huge CSV file is great. And I want to show you some of the code that let's see where here it is. So here's some of the code that from my project at work. And also, I know I showed you most of this stuff in Cypher, but most of the time I'm working in Python. So here's how you do some of the same things in Python. They have a library. You can either call it Py to Neo. Also, it's called Neo4j. It's the same library. And here is where I connect into my machine. So if you know my login and password, it's pretty fancy. And this is connecting to my other container, the other Docker container from this container. So you got to worry about how the network works, but pretty simple. And then here I can start up. In fact, I think I can do this right now. It'd be kind of cool. No, I guess I got to do this first. Is that finished? Yeah. Okay. If this, I don't have a conflict. If I go to that, you start seeing this really cool dashboard that shows you all of the operations. I'm not doing anything right now, so let me go back and do something. Whoops, wait. What did I do? Where did my... Okay, we're back. So if I hit Control Shift, what's it doing? Why is it doing that? Why it's doing that? Hold on. Sorry about that. Maybe that's why. Okay. So now I did that. So basically here I'm starting up the Dask client, and okay, well I already had it running, so that's okay. So now if I start, I put that file. Anyway, you'll start to see some really cool stuff in this screen where it starts doing all its work, and it will really work away pretty quickly. So I just wanted to mention that because it's very useful in paring down huge amounts of data to fit into a graph. So now going back to here, just to show what we covered in this brief time, we went through the movie, The Fraud, the Russian trolls, and I'll give you the links for that when you get going. Then there was Wikidata, a little bit of the NVIDIA to see how that one worked for community detection, just the language there, a little bit about Neptune, and then Dask. And so in summary, it's very powerful. I wanted to give you a breadth of the different tools that are out there. And just to go through this really quickly, this is the instructions of how to get started with Neo4j, how to do all the stuff I did with Wikidata, what you have to do to get CUDA Graph to run, and AWS Neptune, and Dask. And Dask, I just want to point out one thing here with Dask. If you can, let me make this a little bigger. Let's see, how can I make that bigger? Here, so basically in this line here, this one line, I was able to basically parse all the URLs that I cared about in huge file. And it just did that one line, and I can drop columns in another line. So it was really powerful, not just to pull out the pieces that you need, but to pare it down in a way that's more useful to you. There'll be fields you don't need, or fields that have to be altered in some way, and it'll do it really fast. So just want to encourage that. And then a bunch of references in terms of books and sites to go to and things like that. And so that's my whirlwind tour of graph analytics. Hope you're able to stay around most of it. I know I covered a lot, and I'm more than willing to do questions now, but also in the future, I learn a lot from your questions. And so Jason, where are we now?
So we have time to do a couple questions.
Okay.
That definitely was a whirlwind, and so this is recorded, and I think you wanted to make the slides available, right, John?
Yes.
So,
yeah.
Okay.
I'll be sending them after this. Yeah.
So we'll put some resources up. There was a couple questions. I think I had a question, and I'm going to kind of bleed into another question with it. So you talked a lot about, like, a lot of the stuff you were doing was a lot of data exploration. Have you done a lot of work like integrating the graph databases and the graph analytics into like a production system, well, like a web UI and backend and everything without?
I've not done that yet. No, that's kind of the next step we're looking
Okay.
at to do that. I don't see it be any different from machine, another kind of analytic, but yeah.
Okay. And then I guess that kind of feeds. There was a question: what was like some of the most interesting applications or problems you've seen solved with graph analytics? I know you showed a lot of samples, but did you see anything you're reading that was like particularly interesting?
Um, well, the stuff we're doing with insider threat has led to some interesting insights into how people. I think what I think is most powerful about this is the ability to build context. So you're looking across multiple. When you think of someone who's um, when you think of context, context is all about relationships. And context allows you to, because you can look across different dimensions, you can see things clearer that something's not right than something wasn't. So when I can look across your emails and your websites and your telephone traffic and the times you come and go, it gave a whole different picture than if you just looked at one of the dimensions. And that's really what I thought was the most powerful, is that you can just look at multiple dimensions at once and be able to get insight into what's going on. But that the insider thread is the one we're working on right now, and it's had some very interesting views into how we do things, because it's very tricky because all of these we do a lot of anomaly kind of searches, and anomalies are by their nature rare, and an insider threat, thank goodness, is rare. It's a very rare thing. So how do you find something rare? And you can't really look at one dimension and expect to ever find anything that's rare. But if you can look across a whole bunch of them, some things start to point out that, or rule out that somebody was doing something bad or good. So that's kind of a general answer. So I don't really have a real specific one. It's just impressed me across a broad front more than one thing.
Okay, so there was a question about like, do you see this replacing SQL? And I tried to get clarification, and she was talking about the query used for the presidential, but I guess I'm going to make it more general. I mean, where do you see, like, we went through this with like NoSQL databases and things like, a lot of people try to make a push to that or switch over, but relational is still around. Where do you see graph fitting in? Like, do you see graph becoming a larger market of, the backend databases that people are using?
I think it's much more for analysis of data than it's ever going to be for transactional data. So relational sticks around because if I want to buy a movie ticket, I really don't want it to be in Neo4j. I would want it to be in a nice, solid relational database that guarantees that ticket's going to be there. But if you're looking at analysis and trying to see patterns and also throw algorithms to see patterns, a graph's a lot easier to walk through than the same thing in a relational database. So I really see them as different tools because they're for different purposes. And the richness of our, think of another analogy I heard years ago was if you take out your wallet and if you looked at any one thing in your wallet, it probably doesn't say a lot about you, whether you're a real person or not, or whether you're fraudulent. But if I looked at your entire wallet, there should be a consistency to that wallet that should make sense. That consistency will be different for different people. And I think that's when you're looking at the reason why I can look at that differently. Even you could look at a wallet and say something doesn't look right in this wallet. This card shouldn't be here. This doesn't, for this kind of person, this card shouldn't be there. And I think that's all about relationships. That's what it's all about. So I think those kind of patterns come out because of relationships. And machine learning is just looking for relationships too, for patterns also. So they're related to each other, and I'm interested in how they overlap. When do you use one versus another to solve a problem? And the graph, allowing me to jump and hop around to see how things. That's something that machine learning doesn't do. But machine learning, if I can get it down to a number, I can do some interesting things in machine learning. So I kind of see it. They all have different purposes because I've used MongoDB, I've used MySQL, and I even used Accumula for a while, and Neo4j, and I just see them as they're enlarging the pie of what we can do with information. They're not, and there might be some overlap for purpose, but it's not like it's going to replace it. We're always going to have a transactional system that cares about absolute guaranteed consistency. Whereas in an analysis kind of database like Neo4j, I want to be able to add stuff to it all the time. I know that things are going to be not consistent. I'm okay with that, because if I'm loading all that presidential data, I guarantee some of it's wrong. Guarantee it. But I don't want it to break. Whereas a relational database, I want it to break because I want it to be absolutely consistent, that it has guaranteed information, so that that plane ticket's not being sold twice and things like that. So to me, they're different beasts for different things. And people try to say one's going to win versus another. And I don't see that at all. They're just another tool in your tool chest. But graph analytics is much more towards analysis of data, and relational database is much more towards transactions. Although you certainly can do something of each one and each one, but I don't think it's optimized for that.
Okay. There's a couple of questions. Hold on one second. There's a couple of questions about getting started. Like, what was your recommended training? I see you put some references on here, but was there any particular like courses or projects that you were working with? And then like related to that, the person was asking, and I would kind of agree that when you look at like data science, machine learning, and just data engineering, there's always like a lot of different focus areas, and this could be a little niche. Do you feel like graph analytics is something like worth spending an investment for someone that's changing their career or getting into the field, or is this more of a later on thing, like not part of the foundational?
I think I think graph analytics is going to continue to grow. I mean, there's a lot of attention being spent. I mean, I don't know how many people out there use medium.com, but I learn a lot from medium.com. I highly recommend it. And there's tons of articles on graph analytics and graph algorithms. I think it has a role to play that's very different than the other databases. And when you think about how much of our information is relationship based as opposed to just sheer what the value is, or think of a row of information is not the same as how rows are related to other rows. And I think that graphs are more natural to express how we do stuff, and we're just going to get smarter in how to walk across a graph and how to use a graph better. So I think it's a huge area. I think it's going to be big, but it also crosses right over into machine learning. So to me, to have both tools in your tool chest is a good thing. I mean, I always believe in expanding your tool chest, and we're kind of engineering problems, and the tool chest is going to change over time, and this is certainly one that I've found really fascinating to apply to different problems, and I think has a lot of legs. But everybody's got to bet on what they want, because you only have so many hours in the day to read a book or whatever. But I think it's very powerful, and it's related to and augments machine learning. So that's my main focus.
So there was another question that was kind of like related to one I asked a while ago, but I was just wondering, have you seen anybody put together things where they put together relational and graph and like have applications that are kind of using both? And is there any like best practices or design patterns for that kind of thing with graph databases?
I mean, to me, it's like you have two different tools. If you had, let's say you wanted to, you were running a major venue for concerts, you would certainly want a relational database to sell the tickets, but you might want a graph database to analyze how you could sell more tickets, and what groups work, what kind of people are coming to these concerts, what kind of food they're buying. All that would be analysis that a graph could help you with. But you'd still want the relational database to sell the tickets. So I see them definitely working together.
And this is the last question. And it's kind of a little different. And you had talked about it at least a little at the beginning, and I think I know a little bit. But I was wondering, there was a question about your career path, and actually I was kind of interested in it myself now, because you seem pretty, you're doing IRAD and you're kind of like always a tinker, and I was just wondering if you got like a couple minutes, if you could just give some advice of like what you did and like your path, and
Yeah,
any suggestions for folks.
I've had a strange path. I started out in Bell Labs as a full nerd, and then I said, hey, I got to do all these bigger things, and went on to do all these management things, and basically I didn't like any of that. This was the thing I learned about management, is I thought I'd be dealing with all the good people and doing cool stuff, but instead you're bogged down by all the bad people, and you want the cool people just to leave them alone so they can do the cool stuff. And then I said, I'm getting back to my roots. I love building systems and learning, and I didn't want to be the manager who thought he knew stuff but didn't, because I knew a lot of those people that would tell you how to do. So I'm definitely biased towards hands-on, um, learning the technologies and playing with it. And it's always been somewhat of a fight, because it seems like a lot of companies, that path they want you to take is you do that for a few years and then you become a manager. And a lot of people are happy with that. I mean, my kids, some of the kids are doing that, but it just wasn't for me. So I was lucky enough. I was out of the real hands-on stuff for a number of years. And then I got back into a company called BBN that was kind of like a Bell Labs-ish company that gave me the time to get my feet back into hands-on, because you do lose it quickly. It's moving fast, and that's the fun of it, I think. There's a quote that I like, says, if you're not living on the edge, you're taking up too much space. And you got to think about that a little bit. But the idea is, I think, I'm an old guy now, and this just keeps me on my toes. So, and in this market, you take graph analytics, you take machine learning, for example, or advanced DevOps. If you look at those fields, every day you can wake up and there's a new acronym, a new technology you never heard of, but nobody's that far ahead of you. It's not like it's been out. It's not like basic linear algebra that's been around for many, many decades, hundreds of years. So nobody's that far ahead, and you can learn this. And I think the access to learning something today is so rich. I'm spoiled as a person with Coursera and Udemy, and I went back for my PhD. I mean, I could just absorb all of it, and I think that the path is out there, and there's multiple paths. So you take, for example, machine learning and how I got involved. If I went straight math into machine learning, I probably wouldn't have gotten it, even though I did all the math years ago. It just would have overwhelmed me. And I found a course that was more towards my fitting in Udemy. And now I've taken all the math courses and I get it, but I don't think that would have worked for me initially. So I think that the secret is, there's so many different paths out there. Find out something that you like. And I certainly could make recommendations if you send me an email about what works for me, but that might not work for you in how they're doing it. But there's so much, like even how much Neo4j puts out there that you can play with. They have another thing that I didn't show, where you can get a little certificate, and it shows a nice little combination of looking at real data for journals, and how different authors have written journals, and they create this whole graph with what writers worked with each other, and then they use machine learning to predict what writers possibly will work with each other in the future. So it married both the graph analytics to understand all the relationships, and then handed it over to machine learning to figure out what would be the likelihood that author one would ever work with author two. And so that's another cool thing. So if you want to go pure graph analytics, I would start at Neo4j's site, their sandbox, and their tutorial that they have. You get a little certificate for. A lot of stuff's there, and you can learn a lot of stuff really well. They have really good documentation, and you can load it up yourself. You can play with all these things yourself, change the Cypher, play with the Python, whatever. That tutorial is in Python, so you can get a whole Python thing. But also there's books just on graph algorithms that work really well. And I'm really interested now in how those three technologies that I was talking about work together. You have CUDA on the high end doing huge graphs, and semantic web doing smaller graphs, but being able to put logic in it. So you have all three of them working together, and then marry that over with machine learning, and man, you've got a tool chest now. That's what I'm always interested in growing your toolbox and knowing when to use something, and don't get too biased. If you have any advice at all, never get too invested in one technology. It will always be replaced. And I've seen people just end their careers that way. And keep on that edge, keep going. So that would be my long answer to that, but that's a big question.
So really quick, what are you gonna look at next? What are you gonna play around with next?
What am I going to play around with next? Well, what my current interest is really how a lot of people, when they talk about machine learning, and you got on this question too with graph analytics, is okay, I developed this great model or a great graph that can do all these cool things, but how does it work in a real system that's robust, it's been tested? And I think that's a really interesting area, because that's where the rubber meets the road. That's where you benefit your customer. That's where you make money. And we're still in an earlier phase now where we don't we spend a lot more time talking about cool models than actually how to implement it. So I've been looking at Kubeflow and some of these other technologies that kind of give you a path, but they don't talk about the system itself. You got this system that has Kafka in it and all this management stuff and GUI, and how do those jive up with the model that you're building almost on a separate line that the data scientists do? How do they all fit together? And we're putting a system together later this year, trying to do all those things on a huge distribution network. So we're looking across a huge customer. We have hundreds of releases. And so that's a big problem, because that's where you really solve it. So that's the next area. Though I'm always out there. I love medium.com because they have relatively short articles that usually have hands-on stuff. So you can get to GitHub and you can actually play with the code and see what they're doing. So I watch that, and I don't know, it's an exciting time. I teach a lot, and I think everybody who's younger is so lucky, because there's so much at your fingertips. All the stuff we're talking about tonight, you could be playing with in the next half hour, and taking a course on it or reading a book on it or whatever. And it's just amazing, because when I grew up, there was no way that was true. And so I'm just in heaven with all the access to information. So that's probably the next area.
Cool. And I think we're gonna end there, John.
Okay.
That was
Thank
that
you,
was a
everybody, for
whirlwind.
hanging in there.
Yeah, so thank you everyone for attending, and I know there was a lot here, so the video will be up. I usually just clean it up just a little bit, and then we'll try to get some slides up. And if you have any questions, you can reach directly out to John. If you can't find his contact, just reach out to me, and I'll put I'll
There
put
it is, if
you
I
in
get
touch.
it back here. So jhebeler@gmail.com.
I think, and you're on LinkedIn. You're
Yeah, I'm on LinkedIn too. That's right. Absolutely right.
so okay.
All
All
right.
right. Well, hopefully I'll see everyone next month, and hopefully in August we'll be back at least doing some in person for those that feel comfortable. Once again, thank you, John.
Thank you.
Awesome. And if you ever need anything, just let me know. But everyone else, have a good night.
All right. Take care.